Alright, now that we have reviewed what we learned in Density Lesson 1, let's continue with our Density Lesson 2. So today we're going to focus on the densities of solids, liquids, and gases, and we're also going to discuss how we use specific gravity to determine if something sinks or if something floats when it's placed in another substance. So think for a minute about the mass and volume of the objects below. We have a volleyball here and a bowling ball here. Which one is more dense and why? What would happen to each if you put them in water? So let's solve the more dense question first. The volleyball would float and the bowling ball would sink quickly if they were placed in water. Since a bowling ball is more dense than water, it sinks. The volleyball is less dense than water, so it floats. If the balls have almost the same volume, why is the bowling ball so much more dense than the volleyball? They're almost the same shape and the same size. What makes one of them more dense and the other less dense? Mass. The bowling ball has more mass in the same amount of space. That's the density relationship. How much mass do you have in a given space? Mass over volume. Density is only mass divided by volume. If the volumes are the same, it must be the amount of mass that is different between the two objects. Here's a comprehension check. If the masses of two substances are the same, but their densities are different, what is the reason? So they both contain the same amount of matter, but they have different densities. How could that be? Their densities are different because even though their masses are the same, their volume is different. Density is a ratio of mass to volume. So if mass between the objects is equal, volume will be different. If the volume of the objects is equal, then mass will be different to change the densities. Let's talk about liquids. We've all been to Nico's or seen salad dressing or had an experience where oil and water mix, and when you shake them up or they're poured out, what is going to happen to the oil and the water in this glass, say in about 5 minutes? What could be the reason that the oil and the water look like this? Why don't they remain all mixed up like they are in this picture? The more dense liquid, the water, sinks under the less dense liquid, the oil. Why do you think all of these liquids are not mixed together? Is there a reason that it's not one big tube of goo? All of these liquids have different densities. Which of the liquids in the picture is the least dense and most dense? How do you know? The liquid on the bottom is more dense. More dense liquids sink, less dense liquids will rise. Let's talk a little bit about gases. Gases are matter. They're usually invisible and we usually think of them as weightless, although they are not. We know gases have volume. You've seen a balloon expand when you blow it up, and we should know from the volume getting to know that the volume of gases depends on 3 things: temperature, pressure, and the size of the container. We also know that a volume has mass. Since gases are matter, they have both volume and mass. Usually it is less mass, or gases have less mass, when you compare them with the masses of liquids and solid. Gases are matter. We know they have volume, we know they have mass. And since they have both volume and mass, they also have density. Density of gases work like the density of liquids. when they are in containers like balloons or bags. The container with the less dense gas rises, and the container with the more dense gas sinks. So let's take a look at a little video that will help us understand this concept.
Are things you can do to show that it exists, just as surely as water in an ocean or sand on a beach exists. You can show that air takes up space. Open a plastic bag and swing it around, or hold the bag up to catch the air in the wind. Then close it up quickly. You've trapped air inside the bag. You can't see the air, but it fills the bag just as much as if it were filled with groceries or paper or old cans. There are other things you can do to show that air exists. You can show that air has weight. You can make a kind of scale using a strip of wood. Attach a balloon to each end of the strip, which you can hang from a table or chair. Make sure the balloons are filled with about the same amount of air. If the balloons with the air inside them weigh about the same, they balance each other like this. But what do you think will happen if you let some of the air out of the blue balloon on the right, out of one of the balloons? To find out, prick a small hole near the knot and watch what happens. Which balloon weighs more? The blue one with the air that has been let out, or the pink one with the air still inside? Here's still another way to prove that air exists. Put a piece of tissue paper in the bottom of a glass. Stick the glass straight down into a tank full of water like this. Then take the glass out. Remove the tissue and see what it feels like. The tissue is dry. What happened? Let's take another look. The tissue is dry because the glass is full of air that prevents the water from getting in and making the tissue wet. Really? Yeah, okay. Another thing you can do with air is move it from one place to another. This jar is full of air, and the dish has water in it. Using this instrument called a syringe, you can move air from the jar into the syringe. As the air moves out of the jar, water from the dish moves in.
So we can see that gases have both volume and mass from the video that we just watched. So let's talk about how hot air or helium balloons float. So we've all seen them across the sky, the hot air balloons, or we've seen pictures or seen them in movies or on videos, and we've all seen helium balloons standing up, just floating in the air. So what gas is outside of both of these balloons? So what gas is here and what gas is here, filling all the blue spaces? If you answered air, you would be correct. What gas is inside the balloon? Well, inside this balloon is hot air. Inside this balloon is helium. How does that help it float or rise? I don't know if your parents told you, but I always heard hot air rises and cold air sinks. The burners in the hot air balloons heat all of the air in here so it becomes less dense than the air around it. This air is cooler and more dense. This air is warmer and less dense. The helium balloons, the gas helium is actually lighter, is less dense than the air around it. Therefore, it floats. So let's double check the learning scale and see where you are now. Can you explain what density is? That would be the ratio of mass divided by volume. Can you calculate density if you're given the mass and volume of a substance or an object? That would be what we did for the warm-up in the review. Can you determine if an object will sink or float in another substance using specific gravity? And can you calculate density if you are not given the mass and volume of the substance? After this lesson, you should be at a solid 2 and working your way towards a 3. Here's our understanding check for density lesson 2. On a sticky note, explain why a kilogram of tomatoes and a kilogram of feathers have different densities since they both have the same mass, which is 1 kilogram. Write your answer on a sticky or a piece of paper and place it in the Density 2 envelope. Make sure to pause the video so you can read the question while you answer it.